We are looking at practice test number 4. Module 4 covers chapters 8 and 9. And now we are looking at chapter 9, inferences from 2 samples.
Among 843 smoking employees of hospitals with the smoking ban, 56 quit smoking 1 year after the ban. Among 703 smoking employees from workplaces without the smoking ban, 27 quit smoking a year after the ban. Is there a significant difference between the two proportions? Use A 0.01 significance level and B construct the 99% confidence interval for the difference between the two proportions.
Right, so let's write the given again. We cut them into 2 pieces, 2 groups. We call them N sub 1 and X sub 1. So 843, X sub 1 is 56. The second group, N sub 2, 703, X sub 2 is 27, and alpha is 0.01. Is there a significant difference between the 2 proportions? So we have the given. We also need to do some calculations. In order to do that, let me remind you of the formulas you need. P bar is x1 plus x2 over n1 plus n2. Z is p1 hat minus p2 hat over the square root of p bar q bar over n1 plus p bar q bar over n2. And p1 hat is x sub 1 over n sub 1. We need to calculate this, so why don't we do it here? P2 hat is x sub 2 over n sub 2. Let's calculate. Q1 hat is 1 minus that. Q2 hat is 1 minus that. So we do those calculations because it's coming up. So again, first and foremost, given. Secondly, using this formula, we need the P bar, and we all remember P1 hat is x sub 1 over n sub 1, and P2 hat is x sub 2 over n sub 2. We need all of those. We calculate them, so we are ready to go with the Testo hypothesis. Now, H0, P1 minus P2 is 0. H1, P1 minus P2 is not equal to 0. Now, I want you to pay attention to this. It's not asking it's less than, it's greater than. Is there a significant difference? So because of the way the question is asking, so it's not equal. And you have a choice of writing P1 minus P2 is 0 or P1 equals P2. If you write P1 equals P2, then this becomes P1 is not equal to P2. Just be consistent. Let's say this is the claim. We are checking that one, which brings us to the second step, which is test statistic. We're going to calculate this. That's why we did all of this work. We are going to calculate the test statistic. Z is P1 hat minus P2 hat over the square root of P bar Q bar over N1 plus P bar Q bar over N sub 2. Calculation is a little bit tedious. We end up with test statistic of 2.4319. Alpha is 0.01. That's a critical value. Anytime you're dealing with proportion, the only table you use is the Z table, because it's being approximated by a normal distribution, and one approximation is bad enough. Therefore, we never ever use the T table. Critical value, alpha equals 0.01, Z is plus minus 2.575 from the Z table, from the technology, your choice. So take a look at the graph. As you notice, this is negative 2.575. This is positive 2.575. We are comparing numbers. When we compare this number right here, it is way into the non-rejection region. Therefore, don't reject H0 or fail to reject H0. All of this calculation, comparing the numbers, results in the first part. Look at the first part. Fail to reject the null hypothesis. Then the rest comes with explanation of what we know. So going back, fail to reject the null hypothesis. If you're not rejecting the null hypothesis, you are rejecting H1. So you're rejecting the claim becomes false, and you do the writing. There is not a significant difference between the two proportions. Now, if I were to do by the p-value, and I will show you with technology also, the p-value in this case is as follows. The p-value is the area to the right of the test statistic. If it were right-tailed test, we would be done. Because it's two-tailed test, you have to multiply it by 2. The p-value is this area times 2. So let me show you the technology work. So if you use some sort of a technology such as TI calculator, you plug in the information as it is mentioned here, and it calculates the p here. So what is the p-value? The p-value, I'm going to try to write it here. P-value is equal to 2 times the area to the right of a test statistic, z equals 2.4319. I can't emphasize this enough. It's 2 times that. Why is that? Two-tailed test. So again, a quick recap. You compare the two numbers, critical value and test statistic, or you compare two areas, the p-value versus, in this case, area to the right statistic times 2 because it's a two-tailed test. Let's continue with the question. We are looking at the same question. That's why I have the given. So we are continuing with that, and we are interested in finding 99% confidence interval. Therefore, we use the formulas as follows: p1 hat minus p2 hat plus minus e, where e is the alpha over 2 square root of p1 hat q1 hat over n1 plus p2 hat q2 hat over n2. Because we are using p1 hat and p2 hat q2 hat instead of p bar q bar, the results sometimes may not be the same, just so you know. We go through the process, it's a calculation. And by the way, I want to discuss this number, this z, because we are using 99% confidence interval, and it was a two-tailed test with alpha 0.01, they have identical z-score, 2.575. That was picked up from the previous page. We can use it here. We go through the process. E is calculated as 0.0289. We have P1 hat minus P2 hat, and we had it from the previous page, by the way. We had calculated it for the Z, for the test statistic. And now we are going to add and subtract this number from that, resulting in the following. Here's the confidence interval. Notice we go from negative to positive. Therefore, because the confidence interval limits contain 0, there is not a significant difference between the two proportions. In other words, fail to reject the null hypothesis because 0 is in between. So that means equality. If both of them are negative, then you reject the null hypothesis. If both of them are positive, you do the same thing. Normally, both become negative. It's a left-tail test and it's true. Both become positive if it's a right-tail test and the right tail is true. H1 is true. Let's look at technology. If you use the technology, confidence level of 0.99, this is what you get. Again, -9 e to the power minus 4. That means you put 3 zeros to the left of 9, 0.0009, which is almost the same as this number with a negative number. And the right side, 0.056922. Again, slightly different because calculator uses a lot more decimals than we do. That's the reason.
Company A claims that its yogurt cups contain on average fewer calories than that of a competitor. A sample of 50 such yogurt cups of Company A produced an average of 141 calories per cup with a standard deviation of 5.4 calories. A sample of 40 yogurt cups of a rival Company B produced an average of 144 calories per cup with a standard deviation of 6.3 calories. Assuming that the calories of the yogurt cups for Company A and Company B have different variances, Use a 0.01 significance level to test the claim. Calculate the p-value for the test of previous part and make a decision. Is this decision in agreement with the previous one? Make the 98% confidence intervals for the difference between the two means.
Let's write the given. When you look at the numbers for company A, we're going to call it n sub 1, which is 50, x 1 bar is 141, s1 is 5.4. For the second company, n sub 2 is 40, x2 bar is 144, and s sub 2 is 6.3. So that's the first thing. Now, before we move on, I want to explain that you're dealing with the mean. And when you're dealing with the mean and two populations, normally you need sigma 1 and sigma 2 to use the z table. It doesn't happen in reality. Therefore, that's very hard to use. It just happens sometimes. Normally, we don't use it. Then the next one is that we are using different variances because we don't know anything about the variances of the population for the two. But sometimes we assume equality, and you have to show that they are equal. Generally speaking, this is the best course of action. Of course, if they are dependent, then it becomes a matched pair. So there are various cases. In this case, we are dealing with mu1 and mu2, and we normally use T because sigma 1 and sigma 2 is missing. The other thing I want to make a point, you have a choice. Write down mu1 equals mu2 or write down mu1 minus mu2 equals 0. If you write mu1 minus mu2 equal to 0, perfect. Just make sure you write mu1 minus mu2 is less than 0. In other words, you want to be consistent as to what you write. Now, the next one is the test statistic. We have the formula here. We plug in. I want you to pay attention to this part because when you do the calculation, it's really handy that you pay attention to the numerator. I put the numerator here. Also, I put the denominator because I'm going to need that later on for the second part. So I'm going to use that, and it makes life easier with my calculation. If it's done by hand, it goes pretty fast because I'm keeping this. This results in the test statistic of negative 2.3901. Now, critical value comes from the choice of alpha. Alpha is 0.01. By the way, out there, if you're doing the work on your own, many times alpha is chosen as 0.05, just so you know. Degrees of freedom, the way it works out using the text, we use smaller of the two. One of them is 50 minus 1 makes it 49. One of them is 40 minus 1 makes it 39. So we're going to use smaller of the two, which is 39, if we are using no technology. I'm going to discuss the technology and the differences. So now we do the graphing. Take a look at what happens. When alpha is 0.01 with the critical value of negative 2.426, our test statistic is into the non-rejection region. And by the way, this is not to scale. The idea is that negative 2.3901 is larger than negative 2.426. It makes it to fall in a non-rejection region. That's what matters. It doesn't have to be to scale when we discuss that. Therefore, your decision is very simple. Do not reject H0 or fail to reject H0. So when you are not rejecting H0, that means you're rejecting H1. The claim becomes false. There's not enough evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitor. Now, let's look at the calculator work. We use two sample t-test again. When you do that, you have a choice of pooled, which you say no, because we are not assuming equal variances. And when we plug in, pay attention, we put no here. Here's the result. Now, this is a different result, and I want to explain that to everybody. Notice we chose degrees of freedom to be 39, whereas degrees of freedom here is 77.11. Why is that? Because degrees of freedom is calculated if we use a calculator as follows. It uses this formula. Take a look at this complicated formula. I have it in my PowerPoint. Can it be calculated? Yes. And the calculator does that. But for the sake of the textbook and so forth, they go with the easy way out. It so happened the numbers are so different here that we really get a different result, because 77.11 results in the p-value. The p-value is to the left of test statistic, which is the red area, which is larger than the green area. The p-value is larger than alpha 0.01, and you don't reject H0. However, this is different because this is calculated using technology, which is more precise with a different degrees of freedom. The result is different. If you look at this p-value, this p-value is less than alpha, which means you reject H0. So, and I want you to pay attention to those discrepancies. Let's do the same question with part B. Calculate the p-value was already done. Area to the left of test statistic. We did it with technology class. Area to the left of test statistic, which is negative 2.3901. We don't have that. It's somewhere in between. Test statistic. By the way, we go with positive. Remember that. We go with positive because of the limitation of the table. I want to explain the table. You don't have to worry about that. The degrees of freedom we chose was 39. Those are the numbers at the bottom. And the number that we have is negative 2.3901. We go with the positive one, and positive is between these two numbers, and the areas are between these two numbers. Therefore, the p-value, if you were to use the table, would be between those two, clearly larger than alpha 0.01. You get to the same result. This is using the table with degrees of freedom of 39. P-value using degrees of freedom of 39, and we get to the same answer. Now, of course, you remember when we did it with technology, it was a different answer. The reason why, because this 39 really should be 77 something. Even if you go to the table, 77 point something doesn't exist. If you choose the closest number, which is 80, you get to the same result that technology gave us. So I am using the formula x1 bar minus x2 bar plus minus e being this number. And also I'm writing test statistic here on purpose because every calculation that was done in the previous page is supposed to help us. We want x1 minus x2 bar, that is the numerator. We want e, which is t alpha over 2 times this. This part is the denominator of test statistic. Look at this. Therefore, take a look. How do you calculate this? T alpha over 2, that was 2.426. Remember from the previous page, 2.426, the negative one was the critical value. So this is a critical value. You put a positive because we're going to add and subtract, times this number comes from the denominator. This is the answer. And now x1 bar minus x2 bar, which is negative 3, add and subtract this number. We end up with a negative and a positive number. Again, it contains 0 because the confidence interval limits contain 0. There is not a significant difference between the two means. However, if we do this by technology using, let's say, a TI calculator, now here's what we get, everybody. Take a look at this number, minus and minus, minus 5.499, minus 0.5007. Why is it different? Again, I'm showing you the degrees of freedom is different. That's why the result is negative. Because both values are negative, you are going to reject H0 and see both of them are negative. That means it is negative because it was a left tail test. So company A gives us less calories according to that. So we did the test of hypothesis. We used both methods, traditional methods, p-value method, and now the confidence interval. All of them agree if you use 39 degrees of freedom of 39, all of them agree if you use degrees of freedom of 77.11. Now we're going to use equal variances. Again, normally it doesn't happen, but for the sake of argument, it's a good idea to look at it. What if we assume they have equal variances? Now the equation changes, the test statistic changes. Everything else remains the same as far as the first step is concerned. The formula is a little bit more complicated. On a normal basis, we don't use that. So the first step stays the same. The second step, in order to calculate the test statistic, we need to calculate the pooled value here. We do that. So it takes a little bit of a time to get there. And test statistic becomes negative 2.431. In this case, as far as degrees of freedom is concerned, we add them up. So N1 minus 1, so 50 minus 1. N2 minus 1, 40 minus 1. We add them up. And the degrees of freedom is 88. If we use the table, it doesn't exist. We go with 90, and therefore T is negative 2.368. This is close enough. We do the graph. We notice that this is negative 2.368, the critical value. Negative 2.4316, the test statistic is way into the rejection region. This is smaller than this one. Because of that, reject H0. We get a different result. If you are rejecting H0, you're accepting H1. The claim becomes true. There is sufficient evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitor. We got completely a different answer. As far as the p-value is concerned, again, if we want to know what the p-value is from the graph here, that means area to the left of test statistic. Table has its limitation, degrees of freedom. If you go with 90, this number is between these two numbers, and the p-value is between those two numbers, and therefore makes it less than 0.01. You get the same result. I don't suggest you use the table. Now, x1 bar minus x2 bar plus minus e. Again, we are looking at the confidence interval. E is calculated as such. We are using the same t that we got here. And this part, take a look at this one. You see this denominator has been already calculated for us. We use that. Look at this one. This is the denominator, everybody. If you're doing this by hand, it goes very fast if you keep this value. So you have this. X1 bar minus X2 bar was negative 3. Add and subtract this one. And from negative to negative, because the confidence interval limits do not contain 0, there is a significant difference between the two means. In other words, reject the null hypothesis. So a quick recap. We write step 1. Step 2, we have to calculate the test statistic using this complicated formula. Critical value alpha is 0.01. Degrees of freedom, they add up. 50 minus 1 plus 40 minus 1, it's 88. Table doesn't have it. 90 is the closest one, and it does a good job, by the way. So T becomes negative 2.368. Comparison of the two numbers, the traditional method from the graph says reject H0. Rejecting H0, claim becomes true. When you want to do the p-value, it's the area to the left of statistic. The table is a little bit complicated, but I have already explained that. When you want to find the confidence interval, it's pretty easy because you've done a lot of work already. You already have this t, you already have this part from the denominator of your test statistic, and the two values become negative. They don't contain 0. You reject the null hypothesis. By the way, if you want to use the calculator, you can do that for t-test, for t-interval. I highly recommend you do it. This one works out to be pretty close.
Testo claim that weights of male college students have a larger variance than female college students, use a significant level of 0.05, and assume the populations are normal.
Information is given here. So what we do, we just call them N sub 1, S sub 1, so on and so forth. So this is N sub 1, 31, X1 bar, S1 bar, and so on and so forth. So that's the only thing. When we do this type of test, which uses the F test, the F distribution, you use your first group such that it has a larger S. So we choose this to be the larger one. And so let's go with the first step. Now, I want to explain the first step. There are different ways of writing it. There are three different ways. You can write H0 as sigma 1 squared equals sigma 2 squared. If you go with that, because we said larger, and normally we want to make this a right tail test, sigma 1 squared is larger than sigma 2 squared. If you go with this, this is how you write it. You can write sigma 1 squared over sigma 2 squared equals 1. Therefore, sigma 1 squared over sigma 2 squared is larger than 1 for H1. You can even write sigma 1 is equal to sigma 2. Therefore, sigma 1 is larger than sigma 2. I'm writing three different ways. Don't mix and match. You can use any of those three, but do not mix and match. And you may come across all kinds. So I don't want you to be confused. Understand there is a sigma 1 and sigma 2 involved. They may square it or they may not. They may look at the ratio. All of them mean absolutely the same thing. So that's the first thing I want everybody to know. The next one, test statistic, uses a very simple formula, S1 squared over S2 squared. Critical value comes from the choice of alpha. This is a right tail test. Degrees of freedom of the numerator for the first group is 31 minus 1, and degrees of freedom for the denominator is the second group, 29 minus 1. So that's how we arrive at degrees of freedom of N numerator, degrees of freedom of D denominator. And you have to go to the F distribution with alpha 0.05. There are quite a few tables having F distribution. You have to first and foremost pay attention to the choice of alpha. That's the first thing you want to look at, alpha of 0.05. So F table, alpha of 0.05. I know it's hard to read, but all across, you read degrees of freedom as follows. This one is 30. This one is 28. And we end up with the number that is 1.8687. Now we do the drawing. We put the numbers where they belong. This area is 0.05. This critical value is 1.8687. Now look at test statistic and put it in. Where does it go? Somewhere in the non-rejection region here. Therefore, fail to reject the null hypothesis. The claim becomes false. There is not sufficient evidence to support the claim that the weights of male college students have a larger variance than female college students. The claim was H0 in this case. The claim was H1, and we rejected H0. Now, we can use the technology, but before we use that, if I were to find the p-value, this is test statistic, everybody. So it's the area to the right of test statistic because it's a right tail test. If we use the calculator and do the math, it gives us the p-value, which is the area, which is 0.27, way larger than alpha of 0.05, therefore fail to reject the null hypothesis.
Will a person's cholesterol level change if the diet is supplemented by a certain mineral? 6 subjects were pre-tested, and then they took the mineral supplement for a 2-month period. The results follow in the table. Cholesterol level is measured in milligrams per deciliter. A, can it be concluded that the cholesterol level has been changed at alpha equals 0.10? Assume the variable is approximately normally distributed. B, find the 90% confidence interval for the difference between the means.
As I mentioned, when we have two means, if they are independent, sigma 1 and sigma 2 is known, we go with the Z table. Normally, it doesn't happen. They are independent. You don't assume equal variances, or you assume equal variances. In both cases, you do the T distribution. When they are dependent or paired, ultimately, you look at their difference and you do the test of hypothesis on their difference, and that becomes really the previous chapter, one sample t-test in essence. What do I mean by that? You normally don't do something like this by hand, but let's quickly look at it if we were to do this by hand. First of all, d bar is summation of d over n, and s sub t is summation of d minus d bar quantity squared over n minus 1 take a root. This is the same formula we have seen for x. I hope you remember when we had the data and we want to take the average, the mean, we add them up, we divide it by size. Okay, everybody remembers that? So that's the same formula. Instead of using x, we are using d. Sometimes they use lowercase d, sometimes they use uppercase d. I'm choosing to use both of them on purpose, so you are exposed to both cases. So those are the formulas. So first and foremost, let's see how this is evaluated. We look at their difference. So as an example, 210 minus 190 is 20. 235 minus 170 is 65, and you write the rest of it. Now, as far as d bar is concerned, you add them up and you divide by size. Remember, you have 1, 2, 3, 4, 5, 6, n is 6. Okay, so you divide by that. But the reason I'm using more because I want to get to the standard deviation. Again, you're not expected to do this by hand. I want to quickly show you if it's done by hand. In essence, your data is changed to those numbers. After you're done here, this is the data that you're working on. That's all there is to it. Summation gives you 100, square them, add them up, gives you summation of d squared. So we find d bar. This is the same as x bar, which we had, which was summation of x over n. X bar, just as an example to remind you, that's the same thing, working on the difference. Let's calculate the standard deviation using this formula. And again, notice lowercase d, I'm choosing capital D on purpose, back and forth, because you are exposed to both of them in case a different text they use a lower or uppercase. When you calculate, you find S sub. Now, this is a calculation done by hand. So you have 6 pieces of data, you calculate the mean, you calculate the standard deviation. If you were to do this by technology, you clear the list L sub 1 and L sub 2 and store everything in L sub 3. So L sub 1, L sub 2, you can clear L sub 3 also. And you store their difference in L sub 3. Now this gives you this column. L sub 1 minus L sub 2 store L sub 20, 65, negative 2. You see the numbers? And if you do one variable stats, it gives you the answer that you're looking for. Here's your X bar. Take a look at X bar, everybody. Now, as far as SX bar, please make sure you distinguish between this and this one. We are using SX bar because this is a sample. So this is the one, not the other one. And of course, we have here. So if we were to do this so these are the 2 numbers that we need. Let's do the test of hypothesis, which in essence is the t-test for one sample. We write the information from the previous page. Degrees of freedom is n minus 1. This is the formula. I hope you remember the t was x bar minus mu over s over square root of n. So that's the same thing if you assume d is x. Mu sub d, or simply mu, is 0. H1, it is not equal to 0. And that's a claim. It's a two-tailed test. You go through the process of finding the test statistic. That's why we did the calculation in the previous page to be ready for this. By the way, mu sub d always comes from H0, and it's always 0 for us. Sometimes in applications, there may be some difference that you're interested in calculating, but for us, it's always 0. And so test statistic becomes 1.6079. Alpha of 0.1, degrees of freedom of 5 results in t being plus minus 2.015. We look at the graph, and as you can see, the test statistic is way into the non-rejection region. So with the traditional method, comparing the 2 numbers, we do not reject H0. If we don't reject H0, that means we are rejecting H1. If we are rejecting H1, we are rejecting the claim. The claim becomes false. There is not sufficient evidence to support the claim that the mineral changes a person's cholesterol level. If we were to find the p-value, we would find the area to the right of test statistic times 2. Why times 2? Because it's a two-tailed test. So one more time, if I were to find the p-value, I would come up with the area to the right of test statistic, t equals 1.610, and I would multiply by 2. Here's the technology. You are doing the t-test of the previous chapter, one sample, on L sub 3. Look at the p-value, 0.1, let's say 7. 0.17, larger than alpha of 0.1, don't reject H0. So this is your p-value, which was calculated here. This is the p-value. Now, the information from the previous page we write, so we can calculate the 90% confidence interval using, remember, we used to use X bar plus minus E. Now we use D bar plus minus E. D bar is really the same as X bar. And E was T S over square root of N. So we're going to use these formulas with the information from the previous page. We do the calculation. So E is this critical value that we had from the previous page, S, which we had found from the very first page, and over square root of N. Now D bar, add and subtract this number. Therefore, mu or mu of sub D between negative 4.22 and 37.554, it contains 0, fail to reject H0. So you get to the same decision with the confidence interval. Let's look at the technology. You use the T interval. You have a choice of putting L sub 3, or you can even write L1 minus L sub 2. Either way, with a 90% confidence interval, look at the numbers we have here. It is extremely close to what we have. And again, 0 is contained. The decision is not to reject the null hypothesis.